Hello friends, and welcome back to Science with Mr. Ko. In this video, we're going to explore the path of energy as it transforms from one form of energy to another to another. Behold, an apple. There is energy in this apple. Since it's a food, that means I can eat it and get its energy for myself. Scientists measure the amount of energy in an apple in calories. 1 calorie is the amount of energy that would be needed to raise 1 liter of water 1 degree Celsius. And this apple probably has about 90 calories in it as energy. So if I eat this apple, by the time I've eaten it all the way down to the core, I'll have about 90 calories of energy in my body. Now, the story of this energy is not going to end there. I'm going to use that energy in a really, really fun way. Yum yum, that was a delicious apple. Now, that apple's 90 calories or so are inside my body. Now, energy comes in lots of different forms. The energy that's in food is called chemical energy. And so now, 90 calories worth of chemical energy are being stored in my body. I feel like I'm ready to use some of that energy up. Let's go for a ride. Riding my bike is one of my favorite things to do. Now, the mechanics of riding a bike are really simple. You just press your feet on the pedals, and the bike moves forward, right? Physics can explain why that happens. You see, when you use your leg muscles to press the pedal forward, or press the pedal down like this, you're transforming some chemical energy from inside your body, from the yummy and healthy and delicious food that you eat, into the mechanical energy needed to move your foot, right? So, when you press your foot on the pedal, the mechanical energy from your foot is going into the pedal. You're giving the energy from your foot to the pedal. Then the pedal is giving that same kinetic energy, the energy of movement, to the chain. The chain carries that same energy to the gears, and the gears give that energy to the wheel. And so, it sounds like a really long journey for that energy, right? But really, it just takes a snap. See? As soon as you press down on that pedal, you can get that wheel moving in a clockwise direction. All right, so here I am with all my protective gear, ready to explain more about how a bike moves forward. So you may remember that when I use my leg to push the pedal forward, it's going to transmit kinetic energy all the way back to the rear wheel here. That's going to make the rear wheel turn clockwise, like this. So, because it's turning that way, the little part of the wheel that's touching the ground is pushing this way on the ground, right? Since that's happening, Newton's third law says that for that action, there's an equal and opposite reaction. That reaction is that the bike moves in a predictable way. Forward! Yeehaw! Meow! But then eventually, you're going to want to stop. And so you have to use your brakes. More on how brakes work in a minute. So stopping your bike is just as important as getting it moving, of course. And to stop your bike, of course, you use your brakes. Brakes have the job of converting the kinetic energy of your bike moving forward into different forms of energy, because we don't want to be moving anymore, so we want to get rid of our kinetic energy. Of course, straight up, energy cannot just be destroyed. It can't just be erased and cease to exist. We have to transform it into a different form. Brakes, by clamping down on the discs here, both at the front wheel and the back wheel, provide lots and lots of friction. And when they apply that friction force to the brakes, or to the discs there, they transform the kinetic energy of the wheel moving like this into both sound, because you can hear your brakes working, and heat. So if you use your brakes really hard over a long distance, your brakes are going to heat up a lot. That wouldn't be so good. That's why it's smart, for one thing, to always be riding at a safe speed, and for another thing, to always make sure that when you put the brakes on, you do it in a nice, slow and steady way. Riding your bike is a really great way to get some exercise. Turns out there's some cool science behind it too. I'd love to know your favorite places to ride your bike around here. Maybe I'll see you out there on the trails. Bye! Wrapping things up here, the chemical energy that I got from that apple was transformed first into the kinetic energy of the bike, and then finally into the sound and heat energy when I use the brakes to stop. You can do these same energy transformations when you ride your bike. Maybe I'll see you out there. Bye!